So I was having a conversation a long time ago with a bunch of the brilliant engineers and scientists that work over at the CDC. And they were walking me through, hey, Matt, so there's a problem that we're starting to see on the grid, which is at the intersection of rising temperatures and rising demand on our electrical grid. Well, here's the thing. You can run increasingly more power through, run more energy through a transmission wire. Problem is, you're going to heat that thing up. Insert the joke about, from Star Trek, resistance isn't futile, it's here's the equation. And what you get out of that equation is basically, hey, you can jam more things through it, but resistance is going to increase. When we talk about an electric resistance heater, that's you shove power through something that doesn't like power being shoved through it. And the result is it gets hot. It's the opposite of a superconductor. So what's been happening is that means we've got a little bit of slack, a little bit in our electrical grid. Well, we've been pushing that a little bit more and more over time. So here's what was explained to me. Now, if we get too much increased electrical load in, pick an average subdivision, an average development. Okay, what we can start doing is getting the wires to the point where they're not able to do the thing that they were designed to do, which is run hot during the day and then cool off at night. So if we run too much, then they get hot during the day. And then let's say we quadruple the number of folks with electric cars in the subdivision, and it results in, this is kind of arbitrary, but a significant increased load for 8 hours at night on that chunk of the local distribution
Charging at
system.
night when the wires should be resting.
Now the wires don't get to go to bed and cool down overnight. Now they're pulling double shifts and they're staying hot overnight, which means physics, they're still hot. They're even hotter going into the next day than they should be. And if you repeat this too many times, look, there's fail safes that are going to trip before the wires melt. Because grid operators and utility operators have solved this problem. There's a certain point at which the circuit breakers trip. But imagine you didn't have those circuit breakers trip. Literally what we do is we run those wires until they just slag off, and then you have fires and melted wires, and that's a whole big problem, and the grid shuts down. So yes, if we don't do the things we need to take care of the grid, that's a very real problem that we're going to face. And by the way, I had that conversation 7 years ago.